Good evening, everybody, and thank you for joining our talk, Redis or Not, Argo CD and GitOps Critical Vulnerability from an Attacker's Perspective. Now, just to get a general idea of our audience today, please raise your hand if you've ever heard about GitOps or Argo CD. Okay. Now, please raise your hand if you're interested in hearing about GitOps hacking shenanigans. Okay, more people, so that's good. So let's begin. In our talk today, we'll have 4 key steps. First, we will explain why we identified GitOps and Argo CD as emerging technologies worth researching. Then, we will study GitOps, exploring how it operates and how does it look like from an attacker's perspective. Then, for the main part of this talk, we will share our research story, detailing how we discovered a critical vulnerability in the most popular GitOps tool, Argo CD, as well as sharing insights on how to conduct a similar research. And finally, we'll wrap everything up by discussing just a little bit security principles for you to take home or maybe pass on to someone who needs them. A word about us. My name is Oreen. I'm a security researcher for 7 years now. I used to research Kerberos and networking, and currently I research application and cloud security.
Thank you, Oreen. I'm Elad. I'm a security researcher at Psycode. I have 7 years of cybersecurity experience. In the past, I researched IoTs, and currently I'm focusing on web applications and supply chain security.
Thank you. So let's begin with identifying a trend, GitOps. But before that, I want to share with you the story of how the idea for this talk even came to life. But it's not for publication, so keep it between us. In 2023, we tried to get accepted to KubeCon North America, and we really thought our talks would make it. However, they were rejected, which left us surprised and frustrated. So for the next KubeCon, as security researchers, we decided to take a shrewd approach to improve our chances of acceptance. We reviewed last year's KubeCon schedule to try and identify technology trends that might reveal some security blind spots. And while we're reviewing the talks, we've noticed that term GitOps, which we weren't familiar with. But the talks were from prominent companies with dramatic titles. As you can see, there was GitOps at Adobe, GitOps at Spotify, and even GitOps changing lives at VMware. So you're like, okay, but do people actually use it, or it's just talking? And apparently, 91% of the respondents in a micro-survey by the CNCF claimed that their organizations already use GitOps. So there is clearly something going on. And from the same micro-survey, they claimed that the most popular GitOps tool was Argo CD. Okay, with over 60% embracement rate. What is exactly Argo CD? We don't know, but as it appears from its website, there are some small organizations that are using Argo CD. So what exactly is GitOps and what is Argo CD? We don't know yet, but it's probably something worth researching. Now I will let Elad explain what they are.
Thank you, Oreen. So, coming to this research, we wanted to know everything about GitOps. Research it from bottom up, inside out, and basically be GitOps gurus. So, first thing first, GitOps is a Git source of truth, meaning all the configuration files, all the resources are being saved in one Git repository. Second is versioning. We are deploying new clusters, new buckets every day, and when something goes wrong, we need to manually figure out what is the problem. But with GitOps, this is a non-issue. All you need to do is go one go back one commit backwards, and your whole environment will be rolled back. And in the end of the day, the current state in the Git repository represents the desired state in the cloud environment. So let's visualize this a little bit. Like I said, all the configuration files are stored in one Git repository. Then we have the GitOps agent that makes sure to be up to date with all the latest changes. And when a new commit comes by, it deploys it to the cloud environment. And from an attacker perspective, the picture looks a little bit more simpler. Attacker wants to get to the cloud environment, right? Because that's the sensitive data, the internal stuff, the production keys, and with direct access to the cloud environment, the GitOps agents, of course, that makes appealing targets in the eyes of attackers. Great. And with the leading GitOps agent, the Argo CD. Argo CD is a GitOps agent that runs inside a cluster in a separated namespace. It's a rising star in the open source community, and also it's a graduated CNCF project. And from eyes of Argo CD, the picture looks very similar. This time we have all the configurations. This time it's a Kubernetes configurations in the Git repository, and Argo CD makes sure to sync them up with the Kubernetes cluster. And in eyes of an attacker, attacking Argo CD looks like a very appealing target. So let's dive in for the exploit part to see how we exploited Argo CD to our advantage to gain elevated permissions within the cluster. So first thing first, we are setting up new Argo CD applications. Doesn't know much about it. Setting this up, pushing some buttons, and creating new applications. Like I said before, setting up a new application requires a Git repository. So we are connecting a Git repository. This time it's a GitHub one with all our configuration files. And one moment goes by, and instantly a cluster is set up, deploying all our deployments, services, network policies to the cluster, and we are synced in, and the cluster is synced with the Git repository. Plug and play process, right? So under the hood, the picture looks a little bit more complicated. First thing first, we are committing a new commit to the Git repository, right? Maybe a new deployment. Then the repository service, a new component along the way, gets notified about those changes. Then those changes are being saved in a Redis instance. That instance is being updated, and later on, a Kubernetes controller is pulling those changes from the Redis cache instance and updates the Kubernetes cluster. And in the end of the day, the current state in the Git repository represents the desired state in the Kubernetes cluster. Amazing. And one interesting component here is the Redis cache instance. It may be like a middleware between the Git repository and the Kubernetes cluster. So we wanted to know a little bit more about that component. Going to the docs, reading a little bit, and we are finding the next line. Secrets are available to anyone who has access to the Redis cache instance. We like secrets, so let's try. We are tunneling our way through to the Redis cache instance, and we get access, totally anonymous access. We are pushing some buttons, and we're finding one pretty interesting manifest key. That manifest key holds all the configuration files from the Git repository in a single place. So we are thinking to ourselves, what if we could inject a malicious deployment straight into the Redis cache instance, and by that, interfering with the Git conventional flow? So let's try. we are crafting our own very malicious deployment that will be privileged to gain us privileged access within the cluster and also create a reverse shell back to an attacker server. So we are crafting our malicious deployment, injecting it to the Redis cache instance, and we wait. We are currently waiting to get a connection from the cluster, maybe a privileged one. A minute goes by, and it failed. It simply failed, it didn't work, and going back to the Redis cache instance, and we see that nothing got changed, and our changes got rolled back. So what happened here? We researched a little bit more, and we knew exactly what happened. We, as an attacker in external namespace within the cluster, tried to inject malicious deployment straight into the Redis cache instance. Then, the repository service got notified about those changes and rolled them back to make sure the current state in the Git repository matches the one in the Redis cache instance. So, what now? Are we finding a new research idea, a new rising trend? I'll let my colleague Oreen continue from here.
Thank you, Elad. It is a complicated point of this talk, but I'll try to do my best. So, how exactly did the repository service know that our application manifest was tampered? Could there be something we've missed? When we went back to the application manifest, we discovered that apparently yes, the first entry of the application manifest, which is named the cache entry hash, and its value seems something like base 64, so could it be some kind of checksum or validation mechanism for the content? Luckily, Argo CD is an open source application. So we dove into the source code and identified this function, the generate cache entry hash, which probably is using some kind of private signing, a private key to sign the content of the application manifest, right? Apparently no. And check out this comment from the source code, and it says, hash the JSON representation into a base 64 algorithm. And check out this part. We don't need a cryptographic hash algorithm since this is only for detecting data corruption. Okay, these are some great news for us, right? Because that means that we can mimic the logic of this function to manually calculate our own cache entry hash to match the new application manifest content. So for the second round of trying to inject a malicious deployment to the Redis instance, we've used the same deployment, which will deploy a privileged pod, who once deployed will spawn a reverse shell to our attacker-controlled server, except that this time we have recalculated the cache entry hash to match the new content of the application manifest. We've inserted the changes and waited for a connection. And this time, it worked. And we received a privileged connection to our attacker-controlled server from within the client's cluster. And when we went back to the Argo CD application, we could now see a new record was added. And within it, that attacker, which is our injected pod, which is now being managed by the Argo CD server that makes sure it's healthy and running all the time. But how would that look like from an attacker's perspective? What could it do? So first, an attacker performing this attack could access the file system of all the pods in the cluster. So just stealing all the information of the pods cluster. Also, he could steal all the secrets within the Kubernetes cluster, as he could now mount himself every resource, every secret he desires. He could also sniff and intercept the pod's networking, as he has network admin capabilities to all the interfaces of the host machine. And also, if you're more into cloud and Kubernetes, he could steal the IAM token of the host machine to start his lateral movement journey in the cloud environment. So either way, it doesn't look good from the victim's perspective. So again, stealing all the secret, sniffing and intercepting all the networking communication, deploying whichever resource it desires to the Kubernetes cluster, and escaping to the cloud environment. Now imagine that any compromised pod in the cluster could perform this attack. Not good. We have reported this vulnerability to the Argo CD team, and they have scored it a critical score of 9.1. We were very happy, obviously. And just to recap this last part, we have learned that any compromised pod in the cluster could inject a malicious deployment to the Redis instance within the Argo CD namespace and deploy whichever resource it desires to the cloud environment. Okay, let's wrap everything up by discussing a little bit of security principles. So based on our research on Argo CD and our broader research on GitOps security, we have gathered a list of GitOps security principles that we believe should be implemented to every organization using GitOps. And there are many security principles, among them cluster separation and network policies, and even Git sanitization. And to make it easier for people to read and pass on to someone else, we have created an open source project called the GitOps Security Champion, which we encourage you to go and read or maybe pass it on to someone who owns a GitOps system, just so we could make sure it's safe. And most important, join and let's collaborate, making GitOps safer. The GitOps Security Champion is in this QR code. We thank you for your time. Thank you for being here. It's a great opportunity speaking in Israel. And again, thank you.